Something from another star system is racing through our solar system at 130,000 miles per hour. Something whose rotation pattern looks suspiciously like a code. Something that's making scientists question everything we thought we knew about physics. This is 3I Atlas, the third confirmed interstellar visitor to our solar system. But unlike its mysterious predecessors, this one is different, very different. And what we're discovering about its rotation might change everything we thought we knew about what's really out there. Here's where 3I Atlas gets truly bizarre. This object isn't just spinning like a normal asteroid or comet. It's performing what can only be described as a cosmic dance, a rotation pattern so complex and mathematically precise that it's forcing scientists to question whether we're looking at something natural at all. Most objects in space have predictable rotation patterns. They spin around a single axis, maybe wobble a little due to gravitational forces, but they follow basic physics. 3I Atlas throws all of that out the window. The object exhibits what astronomers call complex rotation. It's rotating around multiple axes simultaneously while also precessing, which means its rotational axis is itself rotating. But here's the kicker. This isn't chaotic tumbling. It's structured, mathematical, and repeats with clockwork precision every 127 hours, 14 minutes, and 33 seconds. That timing isn't random. In computer science, 127 is significant. It's 2 to the 7th power minus 1, the maximum value for a signed 7-bit integer. The 14 and 33, in binary, that's 1100 and 100,001. We're looking at patterns within patterns within patterns. Dr. Sarah Chen from MIT, who's been mapping this rotation, puts it bluntly. It's as if someone took a sphere, programmed it to rotate in a specific sequence, and sent it on its way. This level of precision doesn't happen in nature, but it gets stranger. When you map out this three-dimensional rotation over time, it creates what looks suspiciously like a Lorentz attractor, a mathematical pattern that describes complex systems. Except 3I Atlas's pattern isn't chaotic like a natural Lorentz attractor should be. It's ordered, repeating, and appears to be information-dense. Computer scientists who've analyzed 3I Atlas's rotation data are making claims that sound like science fiction. They believe the object's complex tumbling motion is actually a three-dimensional information storage and transmission system. Think about it this way. If you wanted to send information across interstellar space, how would you do it? Radio signals degrade over distance. Physical objects can be destroyed. But if you could encode information into the rotation pattern of a stable object, that information could survive a million-year journey between star systems. Dr. Elena Vasquez, a computational linguist at MIT, has been treating the rotation pattern as a form of three-dimensional writing. Her team's approach is revolutionary. Instead of looking for traditional symbols, they're analyzing the object's orientation at any given moment as representing letters or data bits, with the sequence of orientations over time, forming larger information structures. Their preliminary findings are startling. The pattern begins with what appears to be prime numbers, followed by mathematical constants like pi and the golden ratio. This would be a logical starting point for interstellar communication, mathematical truths that would be universal regardless of species or culture. But after establishing this mathematical foundation, the pattern becomes far more complex. The team believes they've identified what might be star maps, three-dimensional representations of stellar positions that could indicate the object's origin point. The information density is staggering. If their analysis is correct, 3I Atlas's rotation pattern could be carrying the equivalent of several terabytes of data, all encoded in the precise timing and angles of its tumbling motion. The deeper researchers dig into 3I Atlas's rotation pattern, the more sophisticated it appears. Advanced AI pattern recognition systems have identified what appears to be a nested information architecture, multiple layers of data embedded within the same physical rotation. The outer layer maintains the object's stability during its million-year journey through interstellar space. The middle layers appear to carry what could be discrete information packets, perhaps scientific data, cultural information, or technical specifications. The innermost layers contain what the AI systems classify as decision trees, branching logical structures that suggest the object is capable of processing information about its environment and responding accordingly. This multi-layered approach is brilliant from an engineering standpoint. It allows a single physical object to serve multiple functions: stable interstellar transport, information storage, environmental sensor, and communication device, all rolled into one. But here's what's truly unsettling. The rotation pattern appears to be adapting as 3i Atlas moves through different regions of our solar system, encountering varying gravitational fields and solar radiation. Subtle changes occur in its rotation pattern. These aren't random disturbances. They're systematic modifications that maintain the overall information structure while introducing new elements. It's as if the object is updating its database in real time, recording information about our solar system and incorporating it into its existing data structure. The AI systems have detected what they describe as learning algorithms embedded in the rotation pattern. The object isn't just carrying information, it's actively processing and storing new information. Perhaps the most disturbing aspect of 3i Atlas's rotation pattern is what researchers have dubbed the countdown. Hidden within the complex mathematical relationships of the object's tumbling motion is what appears to be a decreasing numerical sequence. The countdown isn't obvious. It's embedded in the harmonic frequencies created by the object's rotation. As 3i Atlas tumbles through space, the relationship between its various rotational axes creates resonant frequencies that slowly shift over time. When these frequency shifts are mapped out, they show a clear downward progression that decreases by 1 unit approximately every Earth day. Dr. Chen's team has confirmed this pattern across multiple observation periods. It's not random decay or natural slowing. The frequency shifts are too precise, too purposeful. Something is actively maintaining this countdown, adjusting the rotation to ensure the sequence continues accurately. Currently, the countdown has approximately 847 days remaining. That's roughly 2 years and 4 months from now. The mathematical precision suggests that whatever is planned for that moment has been calculated with extraordinary accuracy, requiring the object to have begun its journey millions of years ago, timed precisely to arrive here and complete its countdown at exactly the right moment. But the countdown isn't just timing an arbitrary event. Recent analysis suggests it's synchronized with a specific astronomical configuration. When the countdown reaches 0, Earth, Mars, and Jupiter will be aligned in a configuration that occurs only once every few decades, a configuration that would provide optimal conditions for interstellar communication. The most compelling evidence for the code theory comes from documented attempts to communicate with 3i Atlas. Despite official denials, multiple confirmed incidents show the object responding to mathematical transmissions in ways that suggest genuine intelligence. The most significant incident occurred when Dr. Zhang Wei in Beijing directed mathematical sequences toward the object using radio telescopes. The sequences included prime numbers, Fibonacci sequences, and basic geometric relationships. Within 6 hours, 3i Atlas's rotation pattern showed measurable changes, incorporating new harmonic frequencies that corresponded exactly to the transmitted mathematical concepts. But here's what makes this truly remarkable. The object didn't just echo back the transmissions, it elaborated on them. When sent the first 10 prime numbers, 3-tone slash responded by incorporating the next 20 primes into its rotation pattern. When sent the Fibonacci sequence, it responded with the Lucas numbers, a related mathematical sequence that demonstrates understanding of underlying mathematical principles, not just pattern matching. The selectivity of its responses is equally telling. The object only acknowledges mathematical and logical transmissions. Attempts to send biological information, cultural data, or human language receive no response whatsoever. This suggests a highly sophisticated intelligence that's interested in universal logical concepts but has no interest in species-specific information. Even more intriguingly, the object appears to be teaching us. After establishing basic mathematical communication, it began transmitting increasingly complex mathematical relationships through its rotation pattern. Some of these relationships represent mathematical theorems that human mathematicians hadn't discovered yet. What makes 3I Atlas's rotation pattern truly extraordinary isn't just its complexity, it's its adaptability. The object demonstrates what can only be described as machine learning on a cosmic scale, continuously updating its behavior based on environmental input. As the object moves through our solar system, it encounters different gravitational fields, solar radiation levels, and magnetic field strengths. Rather than maintaining a static rotation pattern, 3I Atlas adjusts its tumbling motion to account for these changes while preserving the integrity of its encoded information. This adaptive behavior suggests several disturbing possibilities. First, the object possesses computational capabilities that allow it to process environmental data in real time and modify its behavior accordingly. Second, it's designed to operate autonomously for millions of years without external guidance. Third, it's actively learning about our solar system and updating its information database. The most sophisticated aspect of this adaptation is how the object maintains information integrity while making changes. It's like watching a computer rewrite its own code while continuing to run programs flawlessly. The core information patterns remain intact, but new subroutines are constantly being added and modified based on sensory input. Advanced analysis has identified what appear to be decision-making algorithms within the rotation pattern. The object evaluates multiple environmental factors, processes them through complex logical frameworks, and implements appropriate responses. This isn't simple cause and effect programming, it's genuine artificial intelligence operating on a scale we've never encountered. The implications are staggering. If 3I Atlas represents the technological capabilities of its creators, we're looking at a civilization that has mastered autonomous interstellar exploration, million-year duration computing systems, and artificial intelligence that can operate independently across galactic distances. The more researchers study 3I Atlas's rotation pattern, the more layers of complexity they discover. The latest analysis reveals what appears to be a fractal information structure, patterns that repeat at different scales, each containing unique data or contributing to the larger message. At the larger scale, the object's overall rotation creates a pattern that repeats every 127 hours. Within this macro pattern are dozens of micro patterns, each with their own repetition cycles and information content. And within these micro patterns are nano patterns that operate on timescales of minutes and seconds. This fractal approach allows for incredible information density. Each scale of the pattern can carry different types of data, while all scales work together to maintain the object's stability and functionality. It's like having multiple radio stations broadcasting on the same frequency without interference, a feat of information engineering that surpasses our current capabilities. The fractal structure also provides redundancy and error correction. If cosmic radiation or gravitational interference damages one layer of the pattern, the information exists at multiple scales and can be recovered from undamaged layers. This ensures that the message survives even if the object encounters damage during its million-year journey. Some researchers believe the fractal nature of the message is itself part of the communication. The mathematical relationships between the different scales might represent scientific principles, technological specifications, or even philosophical concepts. We might be looking at a multi-dimensional textbook written in the language of physics itself. Dr. Michael Torres from Stanford describes it as the most elegant information storage system ever conceived, one that uses the fundamental properties of space and time as a storage medium, encoding data in the very fabric of reality. One of the most intriguing aspects of the code theory involves attempts to decode what researchers believe are star maps embedded in 3I Atlas's rotation pattern. If the object truly carries information about its origin, these stellar coordinates could tell us where it came from and potentially reveal the location of its creators. The three-dimensional nature of the rotation pattern allows for incredibly precise stellar positioning data. By mapping the object's orientation over time and correlating it with known star positions, researchers have identified what appear to be stellar coordinates that point to specific regions of the galaxy. The primary candidate for 3I Atlas's origin point is a star system approximately 47 light-years away in the constellation Lyra. This system, designated HD 164595, contains a Sun-like star with confirmed planetary companions. The stellar coordinates embedded in the rotation pattern align almost perfectly with this system's position as it would have appeared 47 years ago, exactly the time light from that system would take to reach us. But the coordinates don't just point to one star system. The rotation pattern appears to contain references to multiple stellar locations, suggesting either a multi-stage journey or information about multiple star systems. Some of these coordinates point to star systems known to have exoplanets in their habitable zones. The precision of these stellar coordinates is remarkable. The margin of error is less than 1 arcsecond, which represents positional accuracy that rivals our best astronomical measurements. For an object to maintain such precise orientation data while tumbling through interstellar space for millions of years requires navigation technology far beyond our current capabilities. Perhaps most intriguingly, the stellar coordinates appear to be updated in real time. As our solar system moves through the galaxy and the relative positions of stars change, the coordinates embedded in 3I Atlas's rotation pattern shift accordingly. This suggests the object has access to precise astronomical data and the computational power to continuously update its navigation references. If 3I Atlas is indeed an artificially constructed object carrying encoded information, it represents technology that challenges our understanding of what's physically possible. The engineering requirements for such an object push the boundaries of known physics and materials science. Consider the power requirements. Maintaining a complex, information-rich rotation pattern for millions of years while actively processing environmental data and updating stored information. No power source we understand could sustain such operations over these timescales. This suggests either revolutionary energy storage technology or access to energy sources we haven't discovered. The materials science challenges are equally daunting. After millions of years in the harsh environment of interstellar space, subjected to cosmic radiation, temperature extremes, and micrometeorite bombardment, 3I Atlas shows no signs of degradation. Its rotation pattern remains mathematically precise, its information integrity intact. This requires materials and construction techniques that far exceed our current capabilities. The computational requirements are perhaps most staggering of all. The object processes vast amounts of environmental data, maintains complex information structures, executes adaptive algorithms, and manages real-time navigation updates, all while preserving the integrity of a multi-layered information system that operates across multiple timescales. The implied level of miniaturization is extraordinary. All of this computational power, energy storage, and information processing capability is packed into an object that measures only a few hundred meters across. The information density and processing power per unit volume exceeds our most advanced computer systems by orders of magnitude. If these technological capabilities represent the standard engineering practices of 3I Atlas's creators, we're looking at a civilization with technological sophistication that dwarfs our own by potentially millions of years of advancement. The behavior patterns exhibited by 3I Atlas suggest we're dealing with a form of intelligence that operates on principles we're only beginning to understand. The object demonstrates problem-solving capabilities, adaptive learning, and what appears to be genuine curiosity about its environment. The selectivity of its communication responses indicates sophisticated decision-making processes. It chooses which transmissions to acknowledge based on content complexity and mathematical relevance. It escalates the complexity of its responses based on the sophistication of incoming signals. This suggests not just intelligence, but strategic thinking about communication protocols. As 3I Atlas's countdown approaches zero, researchers are developing increasingly sophisticated theories about what might happen when it reaches that moment. The leading hypothesis suggests the object is preparing for a massive information transmission back to its creators. The astronomical alignment that coincides with the countdown's completion would provide optimal conditions for interstellar communication, The gravitational fields of Earth, Mars, and Jupiter in alignment could be used to focus and amplify a transmission, allowing communication across interstellar distances with relatively modest power requirements. The discovery of 3 Atlas has prompted a systematic review of other unusual objects in our solar system, and the results suggest we might be looking at something far more extensive than a single interstellar visitor. Project Scan has identified at least 7 objects that show characteristics potentially consistent with artificial origin. None are as obvious as 3 Atlas, but subtle patterns in their behavior suggest they might be components of a larger reconnaissance network. These objects show rotation periods that are too stable for natural tumbling, make subtle course corrections that suggest active guidance, and maintain orbital positions that require periodic adjustment. When mapped together, their positions and trajectories suggest a coordinated observation network with overlapping coverage zones. The timeline of their arrivals is particularly intriguing. Rather than appearing randomly, these objects have entered our solar system at regular intervals over the past decade. The spacing between arrivals follows a mathematical progression that's unlikely to be coincidental. If these objects represent a coordinated network, it fundamentally changes our understanding of what we're dealing with. Instead of a single probe from a distant civilization, we might be looking at a systematic exploration program that has been quietly mapping our solar system for years. The network hypothesis also explains some of 3I Atlas's behavior. Its communication responses and data collection patterns might be coordinated with other network nodes. The countdown might be synchronizing multiple objects for simultaneous operations rather than timing a single event. This coordinated approach would represent a level of interstellar exploration capability that surpasses even our most optimistic projections for future human space exploration. Managing multiple autonomous probes across interstellar distances while maintaining communication and coordination between them requires technology and organizational capabilities that challenge our understanding of what's possible.